Number 25 from the energy review paper. In this problem, a bullet is fired into a block of ballistics material, and it's going to go into the ballistics material 0.04 meters. We know that there's a resistive force from that material of 15,000 newtons, and we know the mass of the bullet is 0.1 kilogram. I did not draw a picture for this one because a picture is provided on the review paper for you. Now we're going to start with our energy equation. We've got potential energy 1 plus kinetic energy 1 equals the potential energy 2 plus kinetic energy 2 plus the thermal energy. And now we have to cross out any energies that do not belong. Now initially, we know that it's going to have no potential energy due to gravity because the bullet is not going up or down in this problem. It's staying at the exact same height. So I can cross out the initial potential energy. We are trying to find how fast the bullet is moving before it strikes the block, so we know that it's definitely moving initially, we just don't know how fast, so we're going to leave kinetic energy. When it gets into the ballistics material, it has not gone up or down, so we know that it's got no potential energy at the end of the problem, and we know that it's not moving once it gets into that material, so it's going to have no kinetic energy either. All the energy will have been taken away by friction. So now we're going to expand our kinetic energy term and our thermal energy term. So kinetic energy is 1/2 mv squared, and thermal energy is the force of friction multiplied by the distance that the bullet traveled in that ballistics material. From here, we can rearrange a little bit and solve for velocity. So I'm going to move the 1/2 and the m over. So I'm going to get v squared equals 2 times friction times distance, it's the 1/2 moved over, and divide that by the mass. Now I don't want v squared, I just want v. So I'm going to get rid of the squared by taking the square root of that right side. Now I can plug in some numbers. So I get the square root of 2 times the friction force, which was 15,000 newtons, times the distance, which was 0.04 meters, and the mass of the bullet was 0.1 kilogram. When I plug all those numbers in, I should find an initial speed of 109.5 meters per second. And that is how we do problem number 25.